Hey, so in this lecture I want to talk about the capacity of a string and how we can check for that, how we can get that, and also how we can set that. So in this example I have the string included again, the string file. I have a string str1 for string1. I initialize that to Bob again. And then in this section I just want to emphasize the fact that we have two methods of finding the or returning the size or length of a string in bytes. So we've talked about the size member function and then also the length member function. Now those basically do the same thing. They both are going to return the length or the size of the string in bytes. Now these strings have a capacity as well, so how many characters, the maximum number of characters that the particular string object can store. For example, I can invoke the capacity member function. Basically, capacity is going to return the maximum number of characters that we can currently allocate or store within the particular instance, so in this case string1. And you will see that this is different than the size. Let me build and run that, and you can see that that is going to be different. When we instantiate it, it's going to allocate a capacity or a size for that array that the string object is going to manage. And you can see that is different than the actual size of characters that we currently have allocated. So those two are not necessarily the same. Sometimes they might be the same, but it's not necessarily going to be the same. The capacity is typically a bit larger because of the optimizations that are done. Because as we've seen before, the capacity is not going to limit the length of the string that we can assign to the particular object. We can assign a larger string to it. Then the string object will reallocate the storage space that it manages for those characters. So again, the size or the length is basically the amount of characters that it currently holds, excluding the null terminating character, of course. And then the capacity is how many it can hold before it will have to go and reallocate the storage space to hold a longer string. Now we are not really concerned with the actual implementation of the string class, but this is just to give you a basic idea of what's going on. For example, if you go and assign a different string to string1 now, let's assign some longer string to that, and if I copy this and print out the capacity again, build and run, you will notice that the capacity has updated, and also the size will update, of course. If I go and print out the size, build and run again, you'll see that the size is actually 45, but the capacity is 47. I'll just go and make some changes so we can actually see what prints out here. Build and run again. Alright, so we can see what the string is, the size and the capacity now. One more thing that I want to discuss is that we can actually make a change to the capacity, and we can do that using the reserve function. Okay, so I'm going to allocate this or reserve 80 here, and then I'm going to print this out, build a run, and you can see the capacity is actually not going to be exact. It's going to be a bit larger than what we want. We want to reserve at least 80 bytes, and so it's going to actually give us 95. The standard string implementation again is going to optimize the actual capacity that we get. For example, if we do 25 or something like that, I'll set that to 25, so I'm going to change this here, change that here to 25 as well, build a run, and you will see we actually get 47 still for the capacity. So we can think of this reserve member function as a non-binding request to shrink the size of the managed string capacity, but again it's going to optimize that size. So based on the implementation, we might actually get a size that is greater than n. In this case, what we pass in as an argument, 47 here is greater than 25, which was the requested, the argument that we specified to actually shrink, in this case, the size, because remember beforehand it was 47. So I'll just go back here. This reserve is basically a request to change the capacity. We are not necessarily going to get the capacity that we specify as an argument. Okay, Okay, next I'll go back and I'll change this to something like 80 or 90 as we had it before, so it's larger than what we get with this string allocation. But what if we want to reduce or shrink the reserved capacity? So what I mean by that is, let's say we have a larger capacity here than what we actually have for the size, because remember the size is going to be what we had before. We did not go and modify the string again. So let's say we want to reduce that. So I'll just go and copy this. Okay, so invoke the string to fit member function, which is going to be a request to that string object to reduce its capacity to fit the actual size, which again is now going to be the same as up here, which is down here actually. Let me just build and run that so we can see what we get. Following the reserve of 80, we get actually 95 for the capacity, but then I do the string to fit and then we get 47 again as before. Remember, we changed it up here to this string. We assign the string to string 1, then the size and the capacity changes. Then we go and do the reserve to request a change for the capacity, and then we request the capacity to shrink to fit the actual size, and we get 47 now. So that is how that works. Basically, we are requesting the reduction of the capacity of that string. And of course, you can do this for optimization so that you don't have some huge thing allocated dynamically on the heap that the string object is going to manage. You want to reduce that to optimize your memory usage. And this is an explicit way for you to do this using string to fit. Now you might be thinking, can't we do some sort of a check to see if a string is empty before we invoke some member functions or print it out or something like that? And we actually do have a member function for that. So for example, if I go and select all of this stuff, let's say I'll just do this up here. Instead of the whole thing, I'll just go and do this. Right click, and then I can go and snippet surround with, and not the hashtag or the pound if. I'll scroll down, or you can type, and I'll select if, double click on if. So of course, if you build a run now, this won't actually print out. We have to do not empty. So I'll just do the exclamation. This is going to return a boolean, bool empty. So if it is not empty, then go and print the stuff out. Okay, we get that printed out, the size, the length, and capacity. And then one final thing, we can check what the maximum size is on the machine. Copy this again. This is going to give us the maximum size of the string that can be managed by a string object. So what I'll do is I'll build a run, and we can see that we'll get a huge number like that. So you can see on my machine currently it can manage a huge string. Okay, so that's going to return the maximum size or length of the managed string that the string object is going to manage, right? Okay, as a quick exercise, I'd like you to go and run a program similar to this one. I have a string which is currently empty, and then I'm printing out what the string is, I'm printing out what the size is, and then what the capacity is. So I want you to build it that way. And then following that, what happens if we assign some string to that? So in this case, again, I'm just going to use Bob, and then I'm going to print that out to the size and the capacity. Go ahead and try and see what the differences are. You may want to test this with different sizes of strings. Alright, I'll just continue here and I'll comment this line out. And if I build a run, you'll see that the string is empty. Alright, we get string 1 size is 0. It doesn't have any characters in there other than maybe the null character, but we're not concerned with that with this. And then string 1 capacity is 15. So the capacity is 15 even though the size is 0. And that's an optimization thing. We can assign a bunch of shorter strings to this without it having to reallocate the size of the managed string that the string object manages, right? So now I can go and uncomment this. If I build a run, the string is going to be Bob, the size is going to be 3, it has 3 characters, and the capacity is going to remain 15, unless of course that string is longer. Okay, and that basically wraps up what I wanted to discuss in this lecture with regards to the capacity of the string objects. You don't really have to remember all of this stuff. You can always just refer to the documentation on the member functions on CPP reference, for example, or C++.com.